Greetings, Saintsmen. Welcome to lesson 6.4, triangle midsegment theorem. The midsegment of a triangle works as follows. So it's effectively utilizing that same idea, not of the median, right, but considering midpoints that we're going to have here. So for example, we're going to take this triangle. We're going to call this guy ABC. In triangle ABC, we're going to have some midpoints here, which of course is going to create another triangle, right? These midpoints, we're going to call this M, N, and P, okay? These are all midpoints. All right, so all being midpoints, excellent. Within that, so what that is going to create, it's going to create some congruence here. So for example, from here to here, we have some congruence. From here to here, we have congruence. And then here to here, we have congruence also, okay? What happens with these mid segments is a few things. So what mid-segments are they are a connection of the midpoints of two sides of a triangle, okay? So this is not going to create concurrency. For example, if I just connect from N to P, right? This guy right here is a mid-segment. Or if I connect from M to N, or from M to P. Now look what it does. It creates a second triangle within interior to our triangle ABC. But there's some special features within this. First of all, mid-segments are parallel. Two, sides opposite they are also one half of sides opposite. Now gentlemen, what we're going to do is we're going to do some coordinate proofs. It's kind of the beginning of coordinate proofs for us, okay? And we don't want to overthink some of these things, but we want to be able to say, and this is something we didn't get into before, we want to be able to say that these things are actually true, right? So let's actually put this in a coordinate plane. We didn't really do this, we didn't kind of take the time when we were working through all those lines of concurrency, but let's do this. We'll take some coordinates, A, which is 2, 5, 2, 3, 4, -1, that's going to be B, and -2, 1, and this is going to be C. Okay, so I'm going to go ahead and connect our dots here, making our triangle. Now we're going to make a mid-segment here. Being here and here. We'll call this guy M, N. And what we're going to do is we're going to prove that MN is a mid-segment. In other words, that it is 1/2 of AC, and also that it is parallel. okay? So in order to do that, first of all, we need to find what those coordinates of M and N are, okay? So if M is truly a midpoint, okay, then we need to figure out M as the midpoint of BC. So M, again, it's going to be 4 minus minus 2 over 2, and then it's going to be 1 minus 1 over 2, which is going to be equal to 3 comma 0, right? 4 plus 2 is 6, divided by 2 is 3. 1 minus 1 is 0, divided by 2 is still just going to be 0. So there's our midpoint there, okay? We also need to find the midpoint of AB, which we're going to call N, right? N winds up being 2 plus 4. Gotta go back, guys. I made a mistake here. On M, it's going to be negative 2 plus 4, right? That's going to be 2 over 2, right? And minus 2 plus 4 is positive 2 over 2, and that's going to be a 1. My apologies. I got a slope mixed up in there. Warming up from the weekend here on Monday morning. So 2 plus 4 over 2, and then 5 minus 1 over 2, okay? So N is going to be 2 plus 4 is 6, divided by 2 is 3. 5 minus 1 is going to be 4, divided by 2 is 2. So there we go, there's N. So now we have these 2 points as MN. What we need to do is we're going to need to find the slope, okay? As well as we're going to have to find distance, all right? So let's actually first deal with this distance. So we have to find what MN is equal to. The distance of MN, all right? Remember the distance formula. Big square root sign, okay? It's going to be the difference of the y's, 2 minus 0 squared plus 3 minus 1 squared. Okay, big square root. It's going to be 2 squared plus 2 squared. Okay, so that's going to be the square root of 4 plus 4, which is rad 8, which simplifies as 2 rad 2, right? 4 times 2, square root of 4 is 2. So that's MN. Now we need to find AC, okay? So let's go back here. AC. Because we're trying to see if what 1/2 of AC is equal to, okay? So AC is going to be 2 minus minus 2 squared plus 5 minus 1 squared, which is equal to 2 plus 2 is 4 squared, 5 minus 1 is 4 squared, equal to 16 plus 16, right? 4 squared is 16, which is going to be rad 32. Square root of 32 is going to be 4 rad 2, all right? Now, that means 1/2 of AC is going to be equal to, right? Because it's going to be 1/2 of 4 rad 2, which is going to be 2 rad 2, okay? So we're actually all set there, okay? These guys are equal, MN and 1/2 AC. And I hope you guys can see that algebraically. MN and 1/2 AC both are equal to 2 rad 2, okay? Now, the other thing that we had to figure out to see if these guys are going to be parallel. So we want to say that AC is parallel to MN. In order to do that, we need to find the slope of AC, okay? So going back here, I'm going to actually minimize this guy a little bit. The slope of AC, so MAC, slope is going to be a walk in the park compared to the distance formula. So it's going to be the difference of the y's, 5 minus 1, right, over 2 minus 2, which is 4 over 4, which is 1. Now we do mn, okay, which is going to be 2 minus 0 over 3 minus 1, which is 2 over 2, which is equal to 1. Gentlemen, these guys are parallel because they have the same slope. All right, so we have actually sufficiently done this algebraically. Let's be a little bit more abstract, okay? Always enjoy these. We're going to do what's called a coordinate proof. This is where we're going to marry together our exploits of geometry, right, and proofs with algebra. Finally, right? This is going to be a lot of fun. Let's take this coordinate here. We're going to call this guy A, which is my origin, 0, 0. And whenever we have these coordinate proofs, it always helps, I think, when we have, when we use the origin, because we know the coordinates of it. We're going to take this point, it's somewhere on the x-axis here, and this guy is going to be called C. Now, on the x-axis, remember, there's no change in y. So we know definitely, right, we have to fill in what our x comma y is. We know what the y is. The y has to be 0, right? It is on the x-axis. It does not vertically change. So that, therefore, it's equal to 0. Now, this next portion is a little bit arbitrary. This guy I'm going to fill in, and this guy's going to be 2p, okay? Then I'm going to have another point here, which is going to be b, which is going to be just randomly, arbitrarily be 2q, comma 2r, okay? Doesn't really matter what it is. And then we can actually create our triangle. Now, what we are going to prove we're going to find the coordinates of F, which is the midpoint of AC. And then we are going to prove FD is parallel to BC, and FD is equal to 1/2 BC. Okay, so coming back over here, this is what we need to actually show here. We have this point right here. This guy is called F. Okay, this guy is the midpoint of AC. We need to figure out what his coordinates are. Love coordinate proofs because why not just use letters? We can be a little bit more arbitrary with what we put in here. So to find the coordinates of F, we have to use the midpoint theorem, right? So we need to say the midpoint, work in blue here, is going to be the sum of the x's, 0 plus 2p all over 2, and the sum of the y's, which is 0 plus 0 over 2, okay? Which is going to be effectively, right, 0 over 2p is 2p over 2, which is just going to be p. 0 plus 0 is going to be 0 over 2. 0 divided by 2 is 0. So it's just going to be p comma 0. Right? So now that we know that, we're going to prove that FD is parallel to BC. So first thing, right, and this would make this right here, it shows that that FB, I'm sorry, what am I doing, FD? Oh, I know why, because I forgot to tell you guys. Let's have D and E here. E and F, these guys are going to be midpoints. Okay. All right. So, it would make is FD right here. This guy would be a midsegment, correct? Okay. We need coordinates then for D as well. Okay. So while we had the direction of finding the coordinates for F, now we also need to find it for D. Well, that's not bad, because if D is a midpoint, then we can actually just employ the midpoint formula, right? D, and it's going to be 0, and it's the midpoint of AB, right? 0 plus 2Q over 2, and then 0 plus 2R over 2. 0 plus 2Q is just 2Q. 2Q over 2, right? The 2's, when you divide them together, just equals 1. So this guy's going to be Q, comma, right? 0 plus 2R is 2R. 2R divided by 2 is just R. This is Q, comma, R, okay? Don't be afraid of these just being variables, all right? This is just a matter of symbol manipulation. So now we need to prove the parallel nature of these things, right? So we need the slope of FD. We also need the slope of BC. Oops. The slope of FD, okay. So it's going to be 0 minus R over P minus Q, okay, which is going to be R over P minus Q. That's okay. That's what our slope is. BC hopefully is going to have the same outcome, okay? So it's going to be 0 minus 2R over 2P minus 2Q, which is negative 2R over 2P minus 2Q. And look at what we can do here. I can factor out it's a negative R up above. That's what I was just looking at. I have a negative 2, okay, R over, I can factor out a 2, and that's going to give me P minus Q. And then I can factor out these 2's, which is going to give me a matching slope. It's going to be negative R, right, over the quantity P minus Q, which, look, is the same slope I had for FD. So our slopes are the same. Now, I have to do the distance formula of FD, okay? Oh, this one's going to be super fun. So FD is equal to square root. I think some of you guys already see how awesome this is going to be. This is going to be Q minus P squared plus R minus 0 squared, okay? And I'm just going to stop right there rather than foiling this thing out, because hopefully what we're going to be able to do, right, R minus 0 is just going to be R squared. Hopefully what we're going to be able to do is just get 1/2 BC to match it. So then we need to go to BC, figure out what this guy's going to be, which is going to be, again, the difference of the x's. So it's going to be 2Q minus 2P squared plus 2R minus 0 squared, okay? Now, something to show you guys here. If you guys are going to factor these things out, it actually is going to be a squared term, okay? So what we wind up having is effectively this. I can factor out this 2, right? And that's going to be Q minus P. And that entire thing will be squared, okay? But if I do that, what it means, right, and then this guy 2 minus R is just going to be 2R, and that's going to be squared, quantity squared. What we wind up with is this guy's going to be a 4 on the outside times the quantity Q minus P. Oops, sorry, this is all big square roots, right? squared plus 2r squared is really going to be 4r squared, okay? So then what we can do here is factor out that 4. So then now we have q minus p, oops, plus r squared, okay? Which is what we had way up above, right? But now I factor out that 4, it gives me a 2 rad q minus p squared plus r squared, okay? And effectively we're done here because look at what we have. Go back up to this top. If we take 1/2 of bc, what that's going to be is it's going to be half of that 2, right? Which is just going to be q minus p squared plus r squared. So take a look. Now this guy is totally equal to what FD was. So then we've proven our case. Complicated, right? Don't worry, these problems do get better for tonight's homework. Watch this. If you know the midsegments, guys, drawing a diagram, I have this guy as A, B, C, and then I'm going to have midsegment D, E, right? And if the given is the following, DE is the midsegment of ABC, we're going to find AC given the following. AE is 4.8. If it's the midsegment, guys, what do you know about E? It means E is a midpoint, so guess what AC is? Don't overthink this. This is a very quick problem. If you need a calculator, that's fine. I encourage it. 4.8 times 2, 9.6. Okay. You're going to be a little bit in the dark here. It's okay, but this is going to be a very algebraically intensive lesson, a lot of symbol manipulation, okay? So yeah, these ones where you have that mid-segment, don't overthink these. It's literally half or 2 times or whatever, okay? Go ahead and get started on your homework. It is posted on Canvas. Good luck.